네, 여러분
Good afternoon, ladies and gentlemen. I am the MC of the 2023 WCE Business Summit, JongDoo. It is a pleasure to greet you. I would like to thank you for joining us despite your busy schedules at this afternoon session. Many people are here with us today. Thank you. This 2023 WCE Business Summit session is hosted by the Ministry of Transportation, Industry and Energy and organized by the Korea Energy Agency. It is to discuss the responsibility of businesses for sustainable future and also the growth strategies for green businesses to meet the challenges of climate change and carbon neutrality. So today's session and tomorrow morning's ESG management session will take place here at the Grand Ballroom of the Convention Hall of BEXCO. We ask for your interest and support. First of all, we have prepared the low carbon energy session under the theme of creating new markets for the climate industry through low carbon energy. Dr. Richard Mueller, who was at the opening session for today, is also here today.
다시 한번 큰 박수 부탁드리겠습니다. 감사합니다.
Once again, a big hand. So let us now commence the 2023 WCE Business Summit Low Carbon Energy Session.
네, 감사합니다.
Thank you. I would first like to invite Vice Minister Kang Kyung-sung of MOTI for his welcome remarks. Please greet him with a big round of applause.
대단히 반갑습니다.
Thank you very much. Pleased to meet you. I would like to take this opportunity to thank Director Keisuke Sadamori of the International Energy Agency and Mr. Ali Izadi, head of the Asia Pacific at BloombergNEF, for participating as the keynote speakers. And I would also like to take this opportunity to thank Professor Kim Jip of Seoul National University, who will be leading our panel discussion. I would like to extend my greetings to all of you here today. From today, we will be hosting the World Climate Industry Expo for the next 3 days, and it is an opportunity for us to display the role and importance of the industry in climate response and also to talk about the way forward. The Business Summit is the first conference of the Expo. It will be an opportunity for us to have a sharing of global policies and technology trends under the topic of low carbon energy and ESG management. Transformation to low carbon energy in order to respond to climate change has become mainstreamed in the world. And at the core of carbon neutrality is the climate industry, and fostering the climate industry is an urgent task on our hands. And therefore, in Korea, we are moving quickly. Last April, the Korean government announced carbon neutrality for 2050, and we have also established and notified the first framework plan for carbon neutrality and green growth. Against this backdrop, we are currently in the process of coming up with a low-carbon energy mix that is rational, logical, and feasible. We will be utilizing SMR, clean hydrogen, and fuel cells. These are some of the new climate industries that we are fostering. The industry is moving very quickly as well. Against the backdrop of technical capabilities, Korean companies are leading various sectors around the world, and we are now proactively participating in the new climate industry and ESG management. Traditionally high carbon-intensive industries such as steel and cement are also working on innovations such as CCUS. The government, in order to support the realistic energy transformation of the companies, will continue to support the efforts by the industry through efforts such as the introduction of CF100, which uses 100% carbon-free energy. We will also provide tax incentives, talent, as well as the commercialization of technology for core climate technology. The topic for this exhibition is Rising Above the Climate Crisis Towards Sustainable Prosperity. In the process of responding to climate change, we need to create new markets and new growth engines. And for this to come true, we need to make sure that global companies become core players. The business leaders present here today, I hope, will be able to meet three goals of corporate growth, climate response, and social responsibility through this summit. Once again, thank you to all those who have made today's summit possible. Let us now commence the business summit. Thank you very much.
Thank you very much, Vice Minister Kang Kyung-sung, for your remarks. Once again, a big round of applause. Thank you. So he delivered insightful words of wisdom. And now it is time to invite our keynote speakers. Today we have two keynote presentations prepared. First of all, from the IEA, we have with us Director Keisuke Sadamori, in charge of energy markets and security. And he will give a presentation on secure and affordable clean energy transition. Please greet IAEA's Director Keisuke Sadamori up onto the stage with a big round of applause.
Distinguished speakers and the guests, ladies and gentlemen, good afternoon. And first of all, thank you very much for including the IEA in this excellent and huge event. I would like to use this opportunity to thank the Korean government, the Korean Energy Agency, Korean Energy Industries, but also the Energy Economic Institute of Korea for making this the opportunity to happen. Thank you very much for this. I think you heard in this morning's the opening plenary session from our executive director that the new clean energy economy is emerging. And that's thanks to technology progress and also strong government policies. And some may have been worried that the current energy crisis may slow down the energy transitions, but in fact, so heightened the energy supply security concerns have led to even stronger policy actions by the governments for accelerating rather than slowing down the transitions. The most notable area is renewables, so solar PV in particular. They are growing very fast. IEA's Renewable 2022 market report forecasts that the renewables will grow expand by 2,400 gigawatts, 2.4 terawatts, in the coming 5 years by 2027. And this growth is equal to the growth in the last 20 years, or the equivalent to the entire installed electricity capacity in China. This and in terms of the various energy policy actions, the Repower Europe plan, or the 14th five-year plan in China, Inflation Reduction Act of the United States, and the ambitious targets in India, Brazil, all drive faster growth. And as you can see, but China continues to lead this growth and providing nearly half of the global renewable capacity in the coming 5 years. With such rapid growth of renewables and also the comeback of nuclear, the decarbonization of a global electricity system is progressing actually steadily. More than 90% of the total demand growth over the next 3 years will be covered by renewables. And also the increase in nuclear generation results from expected recovery in French nuclear output, but also from the new plants starting operations largely in Asia. So the carbon intensity of electricity systems are actually going down, which is a good news. Now, another area of growth is EV, and electric car markets are growing exponentially. So as sales exceeded 10 million in 2022, and the share of electric cars in total sales has more than tripled in only 3 years, from around 4% in 2020 to 14% in 2022. And electric vehicle sales are expected to continue strongly through this year, 2023, and over 2.3 million EVs, electric cars, were sold in only the first quarter, about 25% more than in the same period of last year. And we currently expect to see 14 million in sales by the end of 2023. That's 35% year-on-year increase, with new purchases accelerating in the second half of this year. And electric cars could account for around 18% of total car sales in 2023. And electrification of road transport sector goes beyond cars. So 2 or 3-wheelers are the most electrified market segment today. In emerging markets and the developing economies, they outnumber cars, and over half of India's 3-wheeler registration in 2022 last year were electric. So the commercial vehicle stock is also seeing increasing electrification. So electric light commercial vehicles sales worldwide increased by more than 90% in 2022, despite declines in overall LCV sales. In 2022, nearly 66,000 electric buses and 60,000 medium to heavy duty trucks were sold worldwide, and that represents 4.5% of bus and 1.2% of truck sales. So with such progress in renewables and other low carbon technologies, the IEA's famous World Energy Outlook STEPS scenario stated the policy scenario. The baseline scenario has improved in recent years. So it used to lead to a kind of a catastrophic 3.5 degrees rise before that. This was before the Paris Agreement. But we are approaching finally a peak in fossil fuel demand and the related emissions even under today's policies. And we would see 1 degree shaved off down to 2.5 degrees. If governments implement their NDCs and net zero pledges in full and on time, and if companies follow through with their plans, we are aware that this is a real big if, but if this happens, then this announced pledges scenario puts us on track for a global temperature rise of only 1.7 degrees. But of course, net zero is 0, so that requires even faster transition. Now, the energy transitions have been progressing steadily, as I showed, but at the same time, not fast enough to achieve net zero by 2050. So we need to work on energy transitions harder, and in doing so, energy security must be ensured during the whole process of the transitions, as for instance, any large-scale blackouts that can be attributed to the low carbon decarbonization transition could lead to lower support to transitions by the people. So IEA has been working on the kind of a new concepts of the energy security. That's security of energy transitions. That was initially done under the Italian G20 presidency back in 2021. And there, the first principle is energy efficiency first. So when we look at the kind of a recent performance in global energy intensity, it improved relatively strongly in 2022. This was mentioned by Dr. Birol as well, by around 2%, and that's almost 4 times the rate achieved in the previous 2 years. But, of course, this result comes after 5 years of improvements averaging only 1% per year, and that's far off track from the 4.2%, more than 4%, the annual improvement needed on average over this decade to achieve the global climate goals and align with this net zero pathway. There are some positive signs in 2022. So energy efficiency related investment was up 16%, reaching $560 billion. And that was boosted by COVID recovery packages by the governments around the world. And most of this increase came from the electrification of vehicles. And also sales of heat pumps in 2022 grew by 11%. Policy announcements by key economies around the world are set to increase the overall level of energy efficiency related investment even further, with levels expected to reach $1 trillion in the second half of this decade, as tracked by the IEA's announced policy, APS, announced policy scenario. But this level still needs to be boosted by around a third to be consistent with the levels needed in the IEA net zero scenario. So I said the energy efficiency first, so maybe renewable the second. The earlier slide showed, in my first slide, showed a very strong, robust growth in renewables, but such growth needs to be accompanied by the power system flexibility to integrate those variable renewable sources. In the announced the pledges scenario of the World Energy Outlook, the global power system flexibility would need to double by 2030, with substantial increases in hour-to-hour flexibility needs in all major economies. But when we talk about the flexibility, it's not only about the short-term, hourly, or daily kind of changes, variability, but also about the kind of long-term variability. Last month, in April 2023, IEA released a new report, the Managing Seasonal Variability of Renewables. That's a new report in support of the G7 under the Japanese presidency this year. In future power systems with very high VRE, variable renewable share of more than 70% of annual generations, then weeks with electricity surplus will become more frequent, but so are the long periods of low wind and low solar power productions when other sources become necessary. And such variations will eventually extend to monthly and seasonal or even annual timescales. So managing seasonal variability will depend on the interaction of several parameters, like the profile of electricity demand, which is shown in the red line, the complementarity of solar PV and wind, and also availability of hydropower. For example, in the temperate climate with hot summer, that's on the kind of left one, there's a peak demand in summer due to cooling, but there's also kind of a smaller peak in winter. And the solar PV and wind are rather complementary, but hydro is available basically in summer, less in winter. So as a consequence, there is a gap to be covered both in summer and winter. In tropical systems, on the right, there's lack of complementarity between PV and wind. So hydro generation is concentrated around the rainy season. And that's not enough to compensate the little wind generation. So this leads to a kind of a strong surplus in some months and a big gap, deficit in others. And these are the main results of this parametric the analysis. So modeled future power systems for all climate regions would have more than 70% of annual electricity supply from variable renewables. So shares of electricity supply from thermal power plants, of course, would be limited to 5% to 15%, and that's shown in the left side. That shows the electricity supply. CO2 emissions from these systems would be actually very low. That will be below 50 gram of CO2 per kilowatt hour, and that's 90% less than today, even with the unabated fossil fuel power plants. The middle graph shows how the kind of a short duration, short-term flexibility is supplied in these systems, and various resources are deployed. And that confirms the importance of fostering all flexibility resources. So for example, batteries provide around 40% of these services in tropical and arid zones, being in direct correlation with solar. And demand-side measures such as the smart charging of electric vehicles and also industrial demand responses, they are more important in other regions. But when it comes to the managing seasonal imbalances coming from the VRE, variable renewables, that's in the right-hand side, and only two resources becomes important. One is the legacy thermal assets, provide between the half and two-thirds of seasonal flexibility services in critical periods of the year, and reservoir hydro supplies most of the remaining needs, and depends on the climatic conditions. So in considering this kind of seasonal variability issues and other the matters that are required for the kind of decarbonization, the role of nuclear as dispatchable low-carbon power generation source is becoming more important, in particular for those countries that opt to use it, like the Republic of Korea. With increased energy security concerns and also the climate crisis, we are seeing now a kind of a strong nuclear comeback in countries that opt to use it. So I was in G7 Hiroshima leaders meeting in the last weekend, and the leaders communique from the G7 countries sent a very strong, much stronger than the previous years, and clear message about the role of the nuclear power in clean energy transitions. In terms of the individual countries, Inflation Reduction Act by the United States, and also in Europe, recent decision of a country like Belgium, or Japan's GX plans that was announced at the end of last year, but also the Korea's recent policy changes. They are the good examples. Now, the IEA released a report about half a year ago, almost a year ago, the Nuclear Power and the Secure Energy Transitions Report in June of 2022. And nuclear plays a significant role, should play a significant role in a secure global pathway to net zero. In the net zero emission scenario, the nuclear would have to double from the current more than 400 gigawatts to more than 800 gigawatts, 812 gigawatts in 2050, in the net zero by 2050 scenario. Annual nuclear capacity additions in that case would reach 27 gigawatts per year in the 2030s, and that's higher than in any previous decades. Emerging markets and the developing economies, they account for more than 90% of global growth, with China set to become the largest nuclear power producer before 2030. And advanced economies collectively see a 10% increase in nuclear as retirements are offset by new plants. The industry has to deliver projects on time and on budget to fulfill its role. And this means that completing the nuclear projects in advanced economies at around $5,000 per kilowatt. That's about $5 per watt. That's 40% below the reported costs of the recent first-of-a-kind projects. And for that, stable regulatory frameworks throughout the construction period would be crucial for avoiding delays and the cost overruns. Less nuclear power would make net zero ambitions harder, more expensive, and riskier. The low nuclear case of the net zero emission scenario considers the impact of failing to accelerate the nuclear constructions and also the extending lifetimes, with nuclear share of total generation declines from 10% today to 3% in 2050. Then solar and wind would have to fill the gap. And that places more pressure on these technologies and pushing the frontiers of integrating high shares of variable renewables, including that kind of seasonal variability. And in order to maintain the electricity security, far more battery storage or the carbon capture technologies would become necessary. So, roughly speaking, there are three implications of less nuclear. And first is the increased higher overall costs. So higher investments and also higher fuel costs would cost consumers an extra $20 billion per year over the next 3 decades. Second is the additional strain on clean energy supply chains. So because for every 1 gigawatt less reduction, the 1 gigawatt reduction in nuclear capacity in the low nuclear case, additional 3.5 gigawatt of capacity from other sources would become necessary. And that will lead to a greater call on critical minerals and other technologies for power generation and also the grid infrastructure. Third, all countries and consumers will be exposed to kind of volatilities in natural gas and the coal market prices. As I said, the electricity system with more than 70% renewables, of course, would be very low, will come with a very low carbon intensity. That's 50 gram per kilowatt hour, and that's 90% less than today. But even with the unabated fossil fuel generations. But if we are to aim really seriously to net zero, then these flexibility sources should be also decarbonized. And the possible technological options would be to equip the power plants with the CCUS or to use low carbon fuels in power plants. So projects are going on to demonstrate the technological feasibility of using hydrogen in gas turbines or the co-firing ammonia in coal-fired power plants. Biogas and biomass, they also can decarbonize, contribute to decarbonize the thermal power generations. And there, the hydrogen should play a key role in decarbonizing hard-to-abate sectors. But that requires making hydrogen production clean. Today, hydrogen production is somewhat dominated by unabated fossil fuels. The good news is that pipeline of projects for the production of low-emission hydrogen is growing at a very impressive speed. If all announced projects under development are realized, then the annual production of low-emission hydrogen could reach up to 24 million tons by 2030, with up to 14 million based on the electrolysis, green, and up to 10 million tons of from fossil fuels with CCUS, so blue. They are equivalent to up to 70% of the annual low-emission hydrogen production that is needed to meet the government's climate pledges by 2030. For electrolysis, the realization of all projects in the pipeline could lead to an installed electrolyzer capacity of 134 to 240 gigawatts by 2030. But a planned project is not what we have in the pocket. So only around 4% are already under construction or have reached final investment decision. So this slow progress on the ground, on the real world implementation is due to uncertainties about demand, lack of clarity in regulatory frameworks, and the lack of infrastructure to deliver hydrogen to end users. And one relevant area and what is attracting growing interest is the trade of hydrogen and its derivatives. So Japan and Australia have been spearheading efforts on this front, I think Korea as well. And the world's first shipment of liquefied hydrogen from Australia to Japan took place in February of 2022. And more countries, they're stepping up efforts. Today, the trade of hydrogen and hydrogen-based fuels is limited to a few tons of hydrogen in sporadic shipments from demonstration projects. Based on the kind of export-oriented projects under the development, we estimate that 20 million tons of hydrogen could be exported annually by 2030. The first projects are actually aiming to come online as early as next year. Whether or not these exports are realized is highly uncertain. An important challenge is to secure customers' demand. So offtake and the importing arrangements are lagging behind the scale of planned projects on the export side right now. So now only 2 million tons of hydrogen per year have secured a customer or potential customer. Another 2.5 million tons have identified a specific region to export, but without offtake agreements. And other uncertainties concerns standards, regulations, and certification, lack of trade infrastructure, and the need to clarify how trade rules can apply to hydrogen and its derivatives. So clean energy transitions require a huge expansion of our technology supply. And IEA's ETP, Energy Technology Perspective 2023, shows that a lot of that expansion is underway. The first is electrolyzers. Almost 3 years ago, in 2019, when the IEA released its landmark study, The Future of Hydrogen Report, the global manufacturing capacity for electrolyzers was less than 3 gigawatt per year. By now, it has reached 10 gigawatt per year. And the outlook is rather bright. On the current announcement, the manufacturing capacity for electrolyzers could exceed 100 gigawatt by 2030, which is half the level required to stay on track to the net zero emission pathway by 2050. But not all these announced manufacturing projects might materialize, but the market is dynamic. So it takes only 1 to 3 years to bring the manufacturing facilities online. Second is electric vehicle batteries. Existing manufacturing capacity is already high compared with today's demand, and announced capacity is actually very close to the level required for the IEA's net zero emission pathway. And finally, for solar PV, the manufacturing capacity by 2030 could be as large as what would be needed for a net zero emission by 2050 pathway, if all announced projects would get built. We analyzed more technologies and in the EDP, and the main point is that there is a wave of investments in clean energy technology supply chains underway, much needed for having a chance to limit the temperature rise to 1.5 degrees. And the investments in mining and processing of minerals, as well as in manufacturing of clean energy technologies, must more than triple in the coming years relative to the average over the past 5 years. If every clean energy technology manufacturing plant that is announced as of today gets built, then the investment flowing into the manufacturing would provide 2/3 of what is needed by 2030 to be on track for the net zero by 2050. But there's something that we need to bear in mind. This point was also emphasized by Dr. Fatih Birol this morning. And according to this, the IEA's Energy Technology Perspective 2023, one of the key findings is that clean energy supply chains today are heavily geographically concentrated. So the top 3 producer countries account for around 80% of global production for cobalt, 90% for lithium, and 45% for copper. And the concentration is not limited to mining and processing and refining. The activities shows a very similar or even higher level of geographical concentration. In manufacturing of the new and the emerging clean energy technologies like the batteries, onshore wind, solar PV, heat pumps, and electrolyzers, we also see a consistently high degree of geographical concentration. More than 70% of our production capacity is held by top 3 producer countries. And there, China plays a dominant role virtually everywhere, with one exception being mining. But for any other steps, China is the largest producer country today and is likely to remain for years to come. For some of the key components of solar PV and battery supply chains, China already has huge overcapacity and operates at the low utilization rates. So one of the the item for discussion at the World G7 leaders meeting at the end of last week, and also the point addressed by Dr. Fatih Birol, and also instruction from in the form of communique, was the countries around the world need to work harder for the more a stronger diversity of these sources, and also the resilience in supply chains in order for the clean energy transitions to move ahead smoothly. For the sake of time, I have no time to read all those conclusions, and I don't need to repeat that. But the overall, I think that we believe that energy transition is progressing steadily, but not fast enough. So therefore, we need to work even harder to accelerate it. And in doing so, the new form of energy security should be taken into consideration in order for the solid and smooth energy transitions to happen. So the IEA is ready to provide support to all member countries and the partner countries with our the all technology and all resources approaches in this world. So thank you very much for your attention.
Thank you very much for that informative keynote, Director Sadamori. 네, 다시 한번 정말 포괄적인.
Thank you very much for the comprehensive report, the keynote address. Once again, a big hand for Director Sadamori.
네, 에너지 전환이.
Thank you very much. We can see that energy transmission is happening very slowly, but not fast enough. As we have heard in the presentation, during the panel discussion, we will continue our dialogue. Thank you very much to Director Sadamori once again for that great presentation. Let us go on to the second presentation. The second presentation will be by Mr. Ali Izadi, the head of the Asia Pacific at BloombergNEF. The title is Navigating the Energy Transition. We do have the speaker on the stage already. Please welcome him with a big round of applause.
Good afternoon, ladies and gentlemen. Thank you very much for the kind introduction. I would like to congratulate KEA and the organizers for this insightful event, and I'm really appreciative to Professor Hee Kim for the opportunity to speak to you today. It's my pleasure to share with you analysis my colleagues around the world do on energy transition. We started this morning on a very positive speech by Professor Miller, as well as IEA Executive Director Dr. Fatih Birol. I would like to continue that message by reminding you that despite all the challenges that we've had over the last 3 years with the pandemic, supply chain disruptions, the return of war in Europe, and inflation, we have continued to see investment in energy transition technologies continue to grow. And last year, for the first time, investment in deployment of energy transition technologies exceeded $1 trillion. As Sadamori-san kindly explained earlier, China accounts with the leading share of investment in deployment of these technologies. Just over 54% of the investment last year came from China. You can see Korea has a very respectable global rank of 6, actually higher than its economy size ranking. But unfortunately, as a whole, if we remove China, the rest of G20 is still not investing enough in deployment of energy transition technologies. Now, the good news still is that because of the rapid investment we have seen in manufacturing and deployment of these technologies over the last 13 years, we have seen the cost of solar modules, wind turbines, and lithium-ion battery packs significantly be reduced, to the point that in many markets, for many applications, these technologies no longer need subsidies to be deployed. They're already economically competitive with the incumbent fossil fuel-based technologies. And as Sadamori-san also explained, in the short term, we continue to see deployment of clean power capacity as well as electric vehicle sales accelerate. Now what I would like to do with the remainder of time that I have, walk you through 2 potential scenarios around how the energy system of the world may evolve. These scenarios are somewhat complementary to the IEA scenarios that were presented earlier. The first one, the economic transition scenario, this is if we don't put in any new policies, but we just let technology costs dictate what gets deployed. So purely based on where cost will take us. For the second scenario, on top of technology cost, we'll apply a carbon budget to make sure that we can hit the Paris Agreement goal of keeping global warming by the end of the century to well below 2 degrees. Now let's look at first what the implication of these scenarios are for emissions. Under the economic transition scenario, if we just follow where technology costs take us, we are already looking at energy emissions more or less plateauing within the next couple of years, and then a gradual gentle decline towards 2050. The result of this is a global warming of 2.6 degrees Celsius. This would still be catastrophic for many island nations, and it would still damage, for example, cities such as Busan, those that are facing the ocean. But at the same time, it's still way better than what was previously thought. This means that even with new policies, without any sort of new measures, we can see a peak in emissions. If we apply the carbon budget, based on the maturity of the technologies that we already have and the development readiness of the additional technologies that we will need for hard-to-abate sectors, we can see a realistic pathway to 1.77 degrees Celsius. Now you may wonder, well, what happened to 1.5 degrees Celsius? In the modeling, we actually aimed for that. Unfortunately, because of the built-in amount of emissions already and the lack of maturity of some of the technologies needed, 1.5 degrees still seems very challenging, although as a policy goal, it's critical to still aim for 1.5. Now, the implication of these 2 scenarios for primary energy is, of course, very different. A common thread in both is actually when it comes to coal, very likely 2022 will be the peak for coal consumption globally. Now, under the economic transition scenario, you can see that there's a gradual decline which accelerates over the next couple of years, and then by 2050, we end up with coal consumption somewhere around where we were back in 2000. In the net zero scenario, that of course will not be feasible. We would have to accelerate the decline in coal consumption, and by 2050, the coal that's left in the system would be about 80% lower than today. And all of that coal would either be used as a feedstock or in processes where we are capturing the emissions. In the case of oil, in both scenarios, we see a peak. In the net zero scenario, that peak would be in 2024, just a year from now. In the case of the economic transition scenario, that would be in 2028. And that's primarily because of the maturity of electric vehicle technology. For gas, the two scenarios have a very different picture. Under the economic transition scenario, we actually see a recovery in gas consumption as prices come down from the record highs we experienced last year due to Russia's invasion of Ukraine. And you can see through the end of this decade, gas demand will actually end up being higher than pre-pandemic levels, and thereafter it plateaus. Under the net zero scenario, we would have to also reduce consumption of gas to make sure that the emission pathway is compliant with the carbon budget that we have. In both scenarios, renewables grow, but as you can see in the net zero scenario, we will have a significantly higher share of renewables. Now, earlier, Professor Muller made a very strong comment around the fact that all countries need to contribute to emission reduction. It's certainly true that we can argue that developed economies have a higher share of historical emissions, but the way the carbon budget math works is unless all countries reduce emissions, we're not going to be able to prevent the catastrophic impacts of global warming beyond 2 degrees Celsius. Now, for developed economies, the OECD, they're already on a declining trend, and that trend would have to accelerate towards 2050. For developing economies such as Indonesia and India, they may need an additional couple of years in the net zero scenario, but even for those, we would have to ensure that by 2030, their emissions are below 2019 levels to have a chance to make the carbon budget work. China is somewhere in between. For China, under our net zero scenario, we expect a peak to happen next year. Now, what do these scenarios, how do they compare with what the targets these governments have already set for themselves in 2030, the so-called nationally determined contributions? The good news is, as you can see in the purple bars, which is the result of the economic transition scenario, even for economies such as India, Indonesia, and China, who have relatively very relaxed targets today, if they just allow technology costs dictate how their energy system evolves, they will do a lot better than what their targets say. In fact, for China, we expect, even under the economic transition scenario, China's 2030 emissions would be below 2019 levels. For developed economies, the good news is that majority of them already have 2030 targets that are compliant with our net zero scenario. Interestingly, Germany, that many times wants to position itself as a leader in climate change debates, actually its current target, as you can see, is not compliant with our net zero scenario. It's actually just on par with what our economic transition scenario foresees. The other question that comes up often, and Sadamori-san already explained this a bit, is around the technology mix. Indeed, we fully agree with the IEA outlook that solar and wind will play a really important role in decarbonization. However, on their own, they will be insufficient. We need to remember that the starting point for each country is very different. Take one extreme, France. France's electricity supply already is mostly decarbonized thanks to the high share of nuclear. That means between now and 2050, most of the emission abatement is going to come from increasing the share of electrification in final energy use. And then, yes, that requires some additional renewables. It will, of course, also require other clean fuels beyond electrification. On the other hand, for countries such as China and India, whose power system is still not decarbonized today, they will have to accelerate the decarbonization of their electricity system while at the same time increasing the rates of final electrification. Some of you may notice that the Indonesia bar on this chart looks a bit different with a much larger purple section. That purple is showing carbon capture and storage. In the case of Indonesia, as many of you may be aware, today Indonesia competes with Australia as the largest exporter of coal. It has cheap, abundant amount of coal domestically, but also as an archipelago relatively close to the equator, its renewable resource potential is somewhat limited. For solar, it's actually not that bad. For wind, unfortunately, the wind speeds are relatively low. As a result of that, an economically sustainable, compliant pathway to achieve net zero for Indonesia would require increasing reliance on carbon capture and storage. And I should note that the reason this is very important for Indonesia is also it's one of the countries that has a lot of depleted oil and gas fields that can be a very good source for capturing that carbon. Now let me delve a little bit on what these scenarios mean for specific components of the economy, starting with power. As Professor Müller kindly said, we do have to ensure that all economies can grow in a way that populations can achieve the same standard of living as many developed economies already have today. That means electricity demand will grow no matter whether we are looking at meeting climate goals or not. In the economic transition scenario, you can see that electricity demand in 2050 would be roughly double where we were in 2020. And part of that growth, again, is coming from the transport sector as EVs become more popular across all modes, from two-wheelers to passenger vehicles and buses and commercial vehicles. In the net zero scenario, you can see that electricity demand will be double that of the economic transition scenario because we'll be electrifying a lot of energy uses, but also we will need to use electricity to create clean hydrogen. So roughly 25% of annual electricity demand in 2050 under the net zero scenario would be for clean hydrogen production. On the supply side, under the economic transition scenario, you can already see that solar and wind will end up accounting for the bulk of electricity supply. These are on annual generation normalized basis. In the net zero scenario, this chart may seem like an evolution of the chart to the left of it, but in fact, it's a very different system. Renewables will play a slightly larger role, but they will not be enough. The additional marginal benefits of adding more and more solar and wind to the system becomes less and less in that case, and we have to look at other sources of electricity to complement the generation from solar and wind. In this case, nuclear is very important. Our net zero scenario has a slightly higher amount of nuclear than the IEA. So in our scenario, we end up with 950 gigawatts of nuclear by 2050. Thermal power plants will be very important, but their role will be very different. Today, thermal power plants are used as often what we call base load. So they're run at fairly high capacity factors. In the future, their capacity factors will decline. In some cases, in some locations, we will equip them with carbon capture and storage. But as you can see, in 2050, we still envision around 2,000 gigawatt of gas turbines in the system around the world, where that capacity is not actually equipped with CCS. It's just a capacity that gets rarely used, meaning its emissions will be very low. And as a result of that, those emissions will be easy to be offset. There will also be a role for open cycle gas turbines that are compatible with using hydrogen, as you can see in green. It's just that those turbines, again, their capacity factors will be relatively low. You may ask, well, what about co-firing with, for example, ammonia at coal plants or hydrogen at CCGT gas plants? The challenge with co-firing is that unless you're co-firing at really, really high shares, the emission benefits are really low. And unfortunately, if you want to co-fire at really, really high ratios, the fuel cost is extremely high. As a result of that, when we look at an economically sustainable net zero pathway, in most places we don't really see a role for coal firing. Now you may say, well, this is not consistent with what many companies envision, particularly in Japan and Korea. It's important to remember that for an individual company, they look at their existing asset base. We are modeling what would be most economical from a system level for a country. So what's good for the country is not always necessarily aligned with what's good for an individual company. And for countries, that picture again, of course, looks very different by geography. If you're Australia, you're blessed with abundant land, very high insulation, really good wind speeds. You also have abundant domestic fossil fuels, and again, you also have reservoirs that can be used for carbon capture and storage. In that scenario, if you're Australia, you can go really high on your renewables, and you can balance that out with fossil fuels used in thermal power plants equipped with carbon capture and storage. On the other hand, if you're an island country like Japan, while the renewable resource potential is still relatively high, particularly for offshore wind, you will have to rely on nuclear power because you also have a high population density, and you need nuclear power to be able to actually make up for the shortfall from your renewable resource potential. In countries like China and India, where while they have relatively large landmass, but also still have very, very high population density and very, very large share of heavy industry, again, all the technologies will be very important. Now, what about the other sectors of the economy? In the case of industry, today, of course, depending on the industrial sector, we are already using a diverse set of energy sources. Take steel, for example. Primary steel production, of course, is very dependent on coking coal, but secondary steel production, so the recycling is already relying on electric arc furnaces. In the case of steel, in some locations where you have carbon capture and storage possibility, you will continue using coking coal. In others, for primary steel production, you will rely on reducing the iron ore using clean hydrogen. You can see as a whole, in industry, we see fossil fuel consumption coming down, but it doesn't go to zero. The primary reason for this is also you have applications such as petrochemicals where oil as a feedstock will still be critical. In the end, electricity, which is already competing with coal as being the #1 source of energy for industry, has a higher share by 2050, and we see a role for hydrogen here as well, although that role may seem smaller than some other companies are arguing for today. In the case of transport, for road transport, electrification is primary vector across two-wheelers, passenger vehicles, commercial vehicles, and buses. In most applications, electrification will be enough. When it comes to aviation and marine, in the case of near shore, we can rely on electrification, but for example, for transcontinental shipping as well as trans-Pacific, transatlantic shipping and aviation, these are areas where we'll have to rely on either sustainable aviation fuels derived from bioenergy or methanol or ammonia derived from clean hydrogen for shipping. For buildings, this is again where heat pumps will play an important role through electrification, and in some circumstances then centralized heating powered by energy could be quite efficient as well. Speaking of hydrogen, in terms of application, we should remember that today we already consume about 100 million tons of hydrogen annually. This is, for example, for production of methanol, for production of ammonia that's used in fertilizers. That needs to be decarbonized. On top of that, the largest set of growing demand will come from the steel sector. In the power sector, we do see a niche role, and that niche role is still about 50 million tons annually by 2050, so it's sizable, but it will be very distributed across a set of different countries. For power, you can see carbon capture and storage will be much more critical. After power, cement production as well as the production of hydrogen is where we see the biggest use cases for CCS. Speaking of hydrogen production, Based on our economic analysis, we see electrolysis being the dominant mode, and that electrolysis can be powered by renewables as well as nuclear, depending on the location. In the case of blue hydrogen, we do see some unique circumstances, for example, exports from Middle East to Europe where blue hydrogen may be effective, but in most cases, we see green hydrogen being more economic. The reason for this is that if you believe in blue hydrogen's potential, you're essentially believing in the potential of CCS. But if you believe in potential of CCS, it's much more economic to directly apply that CCS to the application you want to decarbonize and continue using fossil fuels. Because transporting coal, oil, and LNG is a lot cheaper and easier than hydrogen, particularly when it comes to seaborne transport. On that note, when we hear this debate about electrification versus hydrogen, we should remember that there are indeed some applications, such as shipping, as well as steel, where hydrogen will play a much more important role than electrification. But in majority of applications, direct electrification will be the cheapest approach. Now you may wonder, well, okay, great scenarios, and you said these are supposed to be economically realistic. Well, how much is it going to cost? First of all, as Sadamori-san also alluded, we need to significantly scale up the supply of critical minerals that all these technologies need. Now, the challenge here is not so much that we don't physically have the reserves of these minerals. It's the challenge of timely investments in bringing the mines online and also ensuring that the processing and the refining capacity for these raw critical minerals exist. This is an area where still we're unfortunately lagging behind. Even if you take the EV lithium-ion battery supply chain, there has been accelerated investments in cell manufacturing, good investment, timely investment in electrolytes, cathode, anode, and separators. Less so when it comes to the refining of the key minerals, and even less so when it comes to, for example, upstream investment in expanding lithium mining. This is something that needs to be addressed, and some of the measures, such as the Partnership for RISE, the resilient and inclusive supply chain enhancement that the G7 has launched, is going to be very important if we're going to solve these problems. The flip side of this is also this represents a $10 trillion investment opportunity. And this is an area particularly for upstream resource companies, those that are right now focused on oil and gas and coal industry, whose future revenues from oil and gas and coal is potentially threatened by the transition, can potentially tap into. For the energy system itself, we estimate that the net zero scenario would require just under $200 trillion of investment between now and 2050. You can see both in the net zero scenario and the economic transition scenario on the demand side, the EV space is really important. On the supply side, we should remember that the grid is critical. And again, the grid, unfortunately, even in markets where they have relatively good power market regulation, still investment is not enough. This net zero scenario requires about globally $20 trillion of investments in the grid between now and 2050. In terms of the scale of acceleration that we need, for many of these technologies right now, we're at zero. So even though, for example, for heat pumps, we've seen significant acceleration of sales in Europe, we're still globally at a very, very low levels. The number for nuclear may seem like it's looking better, but in reality, the annual nuclear capacity additions that we need is at a rate that we've never achieved. It's much more than the rate that we had back in the heyday of nuclear industry in the 70s and 80s. So again, all across these technologies will have to accelerate the deployment rate. This is my final slide. In today's opening, we heard from Professor Muller's 12 levers. This is about half of that. but fairly similar in line. The first thing is we should ensure that we can accelerate the mature technologies that we have already. So we should make sure that we are not hindering deployment of things like solar, wind, electric vehicles. We also need to ensure that there are measures where investment is going in critical areas such as carbon capture and storage, advanced nuclear, the specific decarbonization solutions to heavy industry. Right now, there is an acceleration investment in some of these areas, but still is not insufficient. The number 6 is the one that I want to draw your attention to most. This is, again, an area where if we do not scale up investment, it's not because there's not enough material out there. It's unfortunately just because we have not taken the action in a timely manner. Thank you very much for your kind attention.
Thank you very much for your informative presentation. 네, 다시 한번 큰 박수 부탁.
Another big round of applause, please.
블룸버그 뉴.
Thank you to Dr. Ali for your presentation. Thank you for telling us about navigating the energy transition.
발제를 들어보.
So we have just heard from our 2 keynote speakers, and I think they share a similar message. Energy transition is taking place at a speed which we need to accelerate further in the future. So now it is time for our panel discussion, and we will be inviting a number of panelists up on stage. As we rearrange the stage, please wait in your seats, and then we will carry on the panel discussion. So we have 4 panelists that we have invited, and also our 2 keynote speakers will also join us during the panel discussion, and we have a moderator joining us as well. The theme here is creating new markets for the climate industry through low carbon energy. And I do believe that we will discuss various issues related to this topic. The panelists represent various different sectors. Let me introduce them one by one. First of all, from Doosan Enerbility, we have with us Executive Vice President Kim JongDoo. And also from POSCO International, we have Head of Energy Business Group, Executive VP Hyeon. We also have from Equinor, Asia Pacific, Senior Vice President Ingun Svergarden, and also from ExxonMobil Korea, we have President Kenan Nariman, who is also the lead country manager. The moderator is Dr. Kim Hee-jip, who is a visiting professor at SNU. So he will be leading us through the panel discussion, and I understand that he will give brief introductions of the panel discussions. The panelists will speak, and also there will be a Q&A. The 2 keynote speakers will also join us to answer questions that are addressed to them. I think that we're ready to begin, so I would like to invite our 2 keynote speakers, Director Keisuke Sadamori, and also from BloombergNEF, Dr. Ali Izadi, and also Dr. Kim Hee-jip, as well as our 4 panelists. Please join us on stage and let us greet them with a big round of applause.
네, 이제 모두 다 무대 위로 모시.
We are just about ready. If we are ready, let us now turn the microphone to our moderator. Thank you very much. It's a great pleasure to meet you. Climate change is indeed a very big challenge ahead of us. Climate change is a very big threat, but if we leverage climate change, we can have business opportunities to create new businesses. And so, how are we able to utilize climate change as a business opportunity? We have invited companies that are actually realizing this opportunity through their companies. And so through the Business Summit today, We will listen to companies that are fostering the climate industry, and we will also listen to their future strategies and have opportunities for discussions and Q&A as well. We have heard 2 keynote presentations. They were excellent indeed. And so let us now listen to the actual companies in the climate industry. How are they actually creating new industries in the climate sector? We do have English speakers and Korean speakers on stage. We have first EVP Kim JongDoo from Doosan Enerbility. This is a company that is very much advanced in the areas of solar and wind energy. So we will listen to EVP Kim JongDoo first.
Yes, good afternoon. I am in charge of the nuclear energy business. My name is Kim JongDoo from Doosan Enerbility. Let me briefly introduce myself. For the past 30 years, I've been working in the nuclear industry, carrying on various roles. I started off as an engineer, and I was in charge of sales and procurement and also business management. So I've taken on a couple of roles. Today, I would like to talk about the small modular reactor SMRs that is gaining prominence as a new low-carbon energy source, and I will talk about what Doosan Enerbility is doing in terms of SMRs. So you may know this, but Doosan Enerbility is a specialized power plant company that handles everything from the supply of equipment for nuclear, coal, thermal, and wind power plants to EPC projects. Considering the recent mega trend of carbon neutrality, Doosan Enerbility is focusing on fostering 4 core businesses, which include gas turbines, hydrogen production, renewable energy, and the small modular reactors, SMRs, which I will touch upon today. SMR refers to a nuclear power plant which, with a smaller capacity and modular design, simply reducing the size alone wouldn't make it competitive. So innovative safety concepts have been introduced to simplify the plant structure and significantly reduce the probability of accidents. SMRs do not require large-scale power plant sites or evacuation areas, making it possible to construct them near urban areas. They are also designed to utilize existing thermal power plant sites. Moreover, the absence of complex containment structures has greatly reduced construction costs and time compared to large-scale nuclear power plants. Recently, due to factors such as carbon neutrality and the sharp increase in LNG prices, the IEA has projected a potential capacity increase of around 25% for nuclear power generation facilities compared to the previous year. Idaho National Lab forecasts that SMRs will account for approximately 30% of future nuclear power plant construction by 2030 and around 50% by 2050. Considering the smaller capacity of SMRs compared to large-scale nuclear power plants, this indicates that the number of projects could significantly increase. The scale of the SMR market varies greatly depending on assumptions and scenarios. Even with a relatively conservative outlook, there is a tremendous volume that surpasses the current global nuclear manufacturing capacity. So this presents a highly promising situation for a nuclear company like ours. Well, it is known that currently there are around 70 types of SMRs under development worldwide, but most of the SMR developers are fabless companies focused on engineering. So these SMR design companies inevitably require collaboration with qualified nuclear reactor manufacturers, processing advanced manufacturing with possessing advanced manufacturing technology and cost competitiveness during the development process. By leveraging the capabilities of nuclear reactor manufacturers, the production feasibility of SMRs can be evaluated, and cost and production timelines can become realistic. Additionally, the significant risks anticipated during initial deployment can be greatly reduced. If you look at the right side of the slide, you can see, as depicted in this diagram, that despite being small-scale nuclear reactors, SMRs have a unified design where the size of reactor is even larger than that of large-scale nuclear power plants, and they possess more complex structures. Therefore, the emerging SMR market represents a significant opportunity for the few SMR manufacturers worldwide in the global supply chain, and at the same time, a big challenge is posed as well. So in the face of these opportunities and challenge, Doosan Enerbility is undergoing innovative manufacturing technology development that completely changes the paradigm from traditional nuclear reactor manufacturing methods. We are developing a process that can produce in a week what used to take months when applying metal powder process, revolutionizing material preparation, machining, and welding tasks. Additionally, we are continuously exploring new welding methods such as electron beam welding and laser cladding welding to shorten production timelines and reduce costs and enhance quality. Moreover, we have incorporated 3D bending technology to manufacture the helical coil-type heat exchangers, which are widely adopted in SMRs. We also plan to gradually implement robot technologies that can precisely weld complex structures. Through the advancement of manufacturing technology, Doosan Enerbility aims to secure competitiveness in the future SMR market. So I would also like to mention that the SMR business holds significance in many aspects from a national perspective as well. The widespread adoption of SMRs domestically and internationally contributes to achieving global carbon neutrality goals with its environmentally friendly portfolio. Additionally, SMRs serve as a powerful means to enhance energy security by reducing fuel imports. Furthermore, from the perspective of exports, well, we can diversify our portfolio with SMRs alongside large-scale nuclear power plants, and this allows for a broader range of offerings. So, securing a substantial portion of global SMR production volume can provide a steady source of business opportunities for Doosan Enerbility and hundreds of our partner companies in the nuclear power plant manufacturing supply chain. Korea has a track record of successfully delivering nuclear power plants on time and within budget with the UAE Baraka project, which is unique in the global nuclear export market. Built upon this track record, Doosan Enerbility and its partner companies will work together to pioneer new SMR markets. Thank you. Yes, thank you very much. So, following his remarks, because we have limited time, I would like to invite the next panelist.
Let us go now to EVP Park Hyeon, who is in charge of energy industry development at POSCO International. Good afternoon. As have been introduced, I am Park Hyeon, in charge of energy industry development at POSCO International. I would like to thank Moti as well as our moderator for this opportunity. Let me take this opportunity to first talk about how POSCO views climate and carbon neutrality and what is the framework that we have. Concerning carbon neutrality, POSCO believes that this is a very severe and serious situation. At the POSCO Group, the need to become carbon neutral not only comes from the Korean government, but the UN, but also from the investors and our customers. They have high expectations about carbon neutrality, and we can really experience their determination to become carbon neutral. And so in 2022, we have announced the 2050 net zero for the steel industry, and we have had a lot of changes ever since that announcement. As you're well aware, we have POSCO Holdings that was the center of the reorganizing of POSCO so that we can reorganize our business portfolio. And because we are centered around the steel industry, we are working on transforming our steel industry into the hydrogen-based system called HyREX. And this HyREX system is not only a system for us, but this is something that we are developing together with steel manufacturers around the world. The goal is to establish a 100 million ton HyREX capacity, and that actually is on par with our largest factory at POSCO. Within the group portfolio, we also have rechargeable batteries, and as you have read in the media, despite many concerns, we were very successful in working with the Argentinian local and central government to secure resources in Argentina so that we can procure materials for rechargeable batteries. And we are also work with Pilbara Mineral of Australia, and from this year we will be able to produce lithium with them. And so I talked about lithium and rechargeable batteries, and based on the core part of our group, we are working on changing the energy mix for the whole of our portfolio. We had two energy companies within POSCO, and they were merged together, called POSCO International this year. This actually holds significance in two different ways. First is about natural gas. Of course, natural gas still emits carbon, but compared to coal, only half of the carbon is emitted. And as we have heard from BloombergNEF, there are two scenarios, the economic transition scenario and the net zero scenario. And you can see that coal decreases right away for the economic transition scenario, but gas is maintained over a long period of time. And I believe that from the economic feasibility aspect, depending on when hydrogen and solar achieves economic feasibility, gas will continue to have a market as a bridge fuel. And so therefore, we continue to think about expanding our business for natural gas and also preparing for the time when we have a larger market for solar and hydrogen, and we can phase out at that point in time. That is why we are working with Myanmar and Indonesia so that we can expand our business there in terms of training. And we also have a LNG terminal in Gwangyang, and we are working on expanding our LNG capacity in Dangjin. And we also have high-capacity turbines that we're able to use. And we believe that we can expand LNG generation to connect that with hydrogen as well. I did mention HyREX. In producing steel, we need to produce hydrogen, and that can be done through blue ammonia or cracking. And so that will lead to immense investments for infrastructure, which will be burdened by POSCO. And we are also thinking about the strategic way to approach these topics. One of the most important businesses within POSCO is renewable energy. Of course, as you're well aware, given the situation in Korea, onshore wind and PVs, it did increase a bit, but it was very difficult to push ahead. But we also have to think about offshore wind. And so we need to make sure that Korea focuses on offshore wind as a part of our renewables. And at this gathering, we have globally renowned companies in the offshore wind sector. And so we do need to collaborate with world-renowned companies so that we can set up these offshore facilities in Shenan and Donghae, which is the EC. And so by 2030, we hope that we can achieve over 2 gigawatts of offshore wind. That is our target. So I did mention some of the challenges that we have ahead, and in order to make sure that we achieve these goals, the industry must make their efforts, but we also need the full-fledged support of the government. And so I look forward to the industry playing its role and the government playing its role. For example, the industry must develop outstanding technology, and we also need to have bold investments in our business portfolio. On the government side, they do need to provide support and also market-based principles. And so I would like to mention that we will do our best to fulfill our roles, and we look forward to the support and the interest of the government. And I hope that the industry and the government work together so that we can walk down the path towards net zero. And as someone in charge of the energy sector within POSCO International, I promise that we will do our part. Thank you very much. Thank you very much.
So,
Let us now go on to our next panelist, representing a very successful company in terms of transition. It used to be an oil and gas company, but now it is making vast efforts for energy transition, representing Equinor, which is a company in Norway. We have a panelist who will be talking about the efforts carried out by Equinor.
company, now you're making big efforts in climate change business. Would you share your activities with us?
And annyeonghaseyo, and hello. I'm Ingen Svegården, and I head up our Asia-Pacific region in Equinor. And as you say, a broad energy company based in Norway. We have a long legacy with oil and gas. But for the last 10 years, we expanded significantly within the areas of renewables and also low-carbon solutions. As part of that journey, we have spent 5 years pursuing offshore wind opportunities here in Korea. And we have a clear ambitions to develop several gigawatts of offshore wind capacity together with our local partners. And that word together is the key word for me today. Because building a sustainable energy future, that means sustainable, affordable, and reliable energy supply is a huge task. That's not something we can do alone. We need to do it together with governments, with industries, and with the society. So how do we do that? And let me use an example from what we do here in Korea, and that's offshore wind. Offshore wind is still a new industry, but we are very confident that this will become a very big industry. And we've been part of that journey from the start, developing offshore wind projects for more than 10 years. Starting out with bottom-fixed project, but now doing more and more floating wind, and we started early. We've had our first pilot in the water for now 15 years. And the first floating offshore wind farm in Scotland, Hyeon, Scotland, has been in operation now for 5 years with record high performance. And as we speak, and this summer, we will finalize the installation of the world's largest floating offshore wind farm in Norway, supplying power to our oil and gas installation, the Hywind Tampen project. With that done, we will operate 48% of the world's total floating wind capacity. And the next major floating wind farm we want to build, well, that's here. We're planning to be outside Ulsan. So Bandebuli project will be 800 megawatts, almost 10 times the size of Hywind Tampen. That's industrial scale. And Korea has the potential to be the center of gravity for the next phase of this journey. So how do we do that? How do we make sure that offshore wind become a reality in Korea? We do it together with governments. We need economies of scale, and then we need efficient execution speed. That means big ambitions that you have in Korea, backed up by actions like predictable, efficient permitting and consenting, and that's still work in progress. We also need to do it together with the industry. Part of why we are so keen of Korea is that you have an excellent heavy industry supply chain already here, with companies that we have worked with for decades, supplying our oil and gas project. Now we want to use the same relations, the same partners to join us with the journey on offshore wind. And that will grow their activities in Korea, but it will also enable Korea to become a hub for global offshore wind industry. We also need to do it together with the local communities. Even though offshore wind farms are out of sight for most people, they still impact the local community, fishermen or neighbors to our infrastructure on shore. And while we need to secure a sustainable coexistence, we are also actively developing new, high-skilled, well-paid and safe jobs. We are also ready to do our part to invest money and innovation and technology to a strong offshore wind industry in Korea. And we made Korea at the center of the Asia-Pacific strategy for our renewable activities in Equinor, because we really believe in the fundamentals of this market. And that we also believe that success here can create success elsewhere in the region and also globally. We are also developing new technology with a wind semi concept, tailor-made for the Korean supply chain and the environmental conditions that we face here. And we also connect the dots with other parts of our business, exploring a broader energy offering to deliver the full suite of the energy supply that this market needs in the future. So I hope that you want to join us on this journey together. Thank you. 감사합니다.
Oh, thank you very much. 이어서
Let us now continue with one of the most successful oil and gas company, ExxonMobil, and we have with us the president of ExxonMobil Korea. And now ExxonMobil is challenging up to new businesses for climate change. And so let's listen to the transformation of ExxonMobil.
your company's efforts in terms of climate change, business opportunities. Thank you.
안녕하세요. Good afternoon. I'd like to thank MOTI and Korea Energy Agency for organizing this event, and Professor Kim for inviting me here. As speakers have noted before me, we are now on a path that has never been walked before. We are on the energy transition. We all need to work together to achieve the net zero future. And I'd like to share with you strategies that ExxonMobil is pursuing in this field. For over 140 years, ExxonMobil has been successfully delivering energy and products needed for societies to develop and evolve economic growth. And our success stems from our ability to evolve to meet changing societal needs and develop new technologies. Our focus remains on providing reliable, affordable energy and supplying products that we all consume daily while reducing our greenhouse gas emissions and helping others do the same. To tackle the climate change, we need large world-scale solutions deployed globally and at much lower cost. This will require unprecedented innovation and collaboration between the industries, governments, universities, and everybody else, and societies. ExxonMobil has a strong track record of bringing innovative approaches to new-to-the-world technologies to market. In 2021, we established our new company called Low Carbon Solutions to leverage our capabilities and help accelerate the world's path to net zero, while doing this at the right scale and with economics. As we reduce emissions from our own operations and products, we're also commercializing low-carbon technologies to help others reduce their emissions. This includes carbon capture and storage, known as CCS, hydrogen and ammonia, and low-emission fuels. These technologies, we believe, are key to reducing emissions in the highest emitting sectors, such as heavy industry, transportation, and power generation. ExxonMobil plans to invest around $17 billion between now and 27 on lower emission initiatives. About 40% of that will be deployed to grow our low-carbon solutions business to help other companies reduce their emissions. The primary factors that will drive growth in this market are increase in the actual or implicit cost of carbon and decrease in the cost of abatement. Technology plays a critical role in bringing down the cost of abatement and accelerating the path to net zero. We're advancing plans for several CCS opportunities around the world to enable large-scale emission reductions, but this will require supportive policy and market demand. Here in Asia Pacific, we're assessing potential for a regional CCS hub that would enable capture and storage of CO2 from industrial activities. We believe this will help industries in the region, including Korea, to achieve their decarbonization goals. We're also leveraging our experience in hydrogen, which when coupled with CCS is likely to play a critical role in low-carbon energy systems. Earlier this year, we announced FEED for our world-scale blue hydrogen project at our Baytown facility, and we're working with customers in Asia-Pacific to deliver blue hydrogen to them. Another critical enabler for the energy transition, as the speakers before me have noted, are supporting government policies as well as bilateral cooperation in the region. The pace of technology development and the energy transition will be largely determined by government policy and regulatory support. Our view is that practical policy solutions will be needed. The policies that recognize the increasing global demand for affordable, reliable energy and products, while enabling the broad development and deployment of lower emission technologies. We applaud the proactive steps taken by governments to progress hydrogen, ammonia, and CCS development. Here in Korea, where we've been operating for 50 years, we welcome the government's efforts in developing policies to certify and incentivize hydrogen and ammonia. Just as we have done since Korea's first LNG deliveries in the 1980s, we look forward to working with our state and private sector partners on developing low-carbon solutions in Korea and help our customers here achieve their decarbonization goals. We believe that a sustained and successful energy transition will need foundation projects that work with today's technologies and today's policies, with the ambition to grow exponentially from that starting point. As my colleague from POSCO has mentioned, we believe that LNG and gas will play a key role in energy transition. We see the momentum building, and we look forward to new partnerships and innovative approaches as we all navigate this journey together. I thank you for your attention, and I look forward to good discussion. Thank you.
Thank you very much.
감사합니다.
여러분께서 들으셨겠.
So you have just heard the world-class companies, the four of them, being represented by our panelists. You've heard how they are carrying out activities to meet the challenge of climate change. There was the talk about SMR and about hydrogen-related efforts, and then offshore wind projects, and then CCS. So you can see that there are various new projects ongoing in this field. So indeed, these were just outstanding presentations by our 4 panelists. Because of the time constraint, I will only be able to ask 1 question per speaker. We have received questions in advance, and so let me give them to our panelists one by one. The first question will go to Director Keisuke Sadamori from IEA. So the question is as follows. Well, during your presentation, so you talked about supply chain concentration, especially when it comes to the rare minerals. We can see around the world the rare earth, where there's considerable concentration. So how can we, what kind of action should we take in order for promoting businesses in this area? So let me ask this question in English again.
Supply chain concentration on the materials, very critical for our energy transition. What specific actions that we should take? Would you please give us your view on it?
Well, thank you very much for the very relevant question. And this is actually a very important issue, because when I was in the Japanese government and was responsible for the kind of trade issues with the Asian neighborhood, and that was 29 to 2010. And that was the year when China suddenly introduced the very strict export control of their rare earth elements, and the Japanese industries were almost in panic. So this is not simple, but it's really good to see, first of all, that many countries around the world, like the Investment Reduction Act of the US, or many other countries, are trying to provide support to their industries in their the low carbon technology supply chain, building more of a kind of stronger and more diverse the clean energy technology supply chain. That includes domestic, but also kind of trying to find kind of multiple sources of the supply. So diversification and enhancing resilience by each country's effort, that is very important. But at the same time, as the kind of international organization, we consider that we have a role to play in terms of enhancing the international cooperation, because it's really important for the countries to work together on this matter. And there's also a proposal that some countries, they introduced the kind of some stockpiling, emergency stockpiling of certain the minerals and elements. So that's something that we can learn from other countries, and thereby learning to build and build their kind of stronger the efforts. But it's not limited to the kind of supply or ensuring supply, but also it's about the technological improvements. So one of the lessons that the Japanese manufacturing industry learned out of that the very difficult situation in 2010 to 11 was that by extensive R&D activities, they can reduce the amount needed for the critical minerals or the rare earth elements to have the same performance from the equipment. So technological improvements, and also kind of a resource efficiency, material efficiency is another aspect that the countries need to explore. And recycling is also a very important part, because the many of those the minerals, and they are in the equipments and the products already that those countries have. So kind of a recycling, technological developments, and ensuring the kind of a recycling system, that's another important one. And also, I think it's highly important for the international community to work on the kind of a ESG aspect of those the supply chains of the critical minerals, because we see that some, the kind of regulations and standards are different country by country, and it's really important to seek for the kind of highest standards available, because that could lead to the pollutions and other societal problems in kind of in the countries that the mining or processing, refining takes place. So all in all, I think that we need to work on many fronts. And we consider that we would like to kind of ensure that the international cooperation can be in place. So that's the reason why our executive director decided to organize critical minerals, the high-level kind of summit meeting on the September 28th. And we would like to move forward on this matter. But thank you for your question.
Thank you very much. 다음은 블룸버그.
Thank you. We will now go to Dr. Ali Izadi of BloombergNEF. He has lived in Korea for a considerable amount of time, and so he's knowledgeable about the Korean situation. This question is to you. One of the most important points for the people in the new industry is the grid issue.
You mentioned that just maybe global situation too, but in Korea specifically, we have a serious grid issue in terms of expanding the renewable energy. What would be potential solutions for that? Any advice for Korean government and us?
Thank you very much. So if I may, I think there's two components to consider. One is ensuring that the existing infrastructure is used in the most efficient manner. One of the challenges in markets such as Korea is that the existing regulations and as well as the administrative rules around grid administration are still not conducive to maximizing the usage of the existing infrastructure for enabling higher renewable integration. Allow me to just delve a little bit on this point. In Europe, many countries under the third EU energy package had to unbundle their grid from generation and retail, and the grid companies had to become truly neutral, and also they were subject to a lot more specific rules around how they allow for dispatch of different technologies. The result of that is most of the grid systems in Europe already operate on real-time basis. They do not necessarily favor who connected to them first, who connected last. But more importantly, they have also invested in softwares and sensors that allow them to do dynamic line rating. What dynamic line rating means is that for short periods of time, you can actually operate the transmission line above the original rated design capacity. The temperature of the line is monitored, and then once that period of time is passed, then you come back down to normal levels and there's no damage to the line. This means that, for example, if you have during times of the day where there's a lot of solar production, you don't necessarily need to build a new line to accommodate that capacity, because the period of time that power needs to be transmitted is relatively short, and actually your existing infrastructure can handle. Today, this is not done in Korea. So you would notice very well in Jeju, many renewable developers complain of high curtailment. This is primarily because the system is not operated in this way. And this is really important because the investment required in the software and sensors is much cheaper than building new grid capacity. So the first issue is really looking at the existing infrastructure and making sure that you have the rules and regulations that allow you to maximize utilization of it. The next issue, of course, is that we are going to need a lot of grid. If you want to accommodate Equinor's offshore wind project, we have to build a grid there, right? There is no grid there. And there, we need to have the mechanisms that allow investment in expansion of the grid. This is, again, another area where many economies, particularly here in Korea, are challenged, because currently Hanjin Korea Electric Power Corporation is the only entity that's allowed to do this. And of course, if that entity is already having financial losses, which KEPCO has, it doesn't have any money left to actually invest in this area. One way to get around this, so for example, in the North Sea, many European countries allowed specific transmission network companies to actually raise funds specifically for those projects. So TenneT, for example, in Germany has done that. And actually a lot of that investment has come from Asia Pacific, including from here in Korea. So some state-owned Korean entities have actually investments in offshore wind grid infrastructure in Europe, but sadly not here because the current regulatory mechanism doesn't allow it.
감사합니다. Thank you very much. The Korean government just announced that they may allow some of the private investment into the grid. So that's a good advice for us. 질문을 계속 또 이어가.
Let us continue with the questions.
그 두산.
Next, I would like to ask a question to Executive VP JongDoo of Doosan Enerbility. So you talked about the SMRs and you emphasized the role of the SMRs. Well, with the commercialization of SMRs, then do you believe that the large nuclear power plants will no longer be in need? How popular do you think that the SMRs will be? Can you explain a little bit about your outlook for SMRs? Yes, thank you very much. Well, some experts in the field of nuclear energy says that with the development of SMR, well, there are some experts who believe that the large nuclear power plants will be replaced 100%, but personally, I do not agree. Because there are unique aspects and strengths of the large nuclear power plants, the MPPs, and so although the initial investment cost is high and also grid is necessary, but nevertheless, at the same time, there are demands for MPPs. There will be countries that still need the large MPPs. And also there will be countries and situations where the SMRs are in need. So in the scenario for net zero, I believe that SMR and the MPPs will both play a significant role. Doosan Enerbility believe that in the nuclear energy market, we believe that SMR and MPP in our portfolio will account for 50% to 50% of our profits. Yes, thank you very much.
Next, let's go to Mr. Park for POSCO International. So POSCO Group is working on the hydrogen steel industry, but I'm sure that cost is an important topic. And so concerning the topic of cost, how do you plan to balance this? How would you make these projects sustainable? Well, that is a question on mind for the overall POSCO group. So reducing carbon emissions and how are we going to respond to cost? And so the economic side and the environmental side is what we need to balance. And I'm sure that this is something that we all need to discuss together. Well, Hyrex, which is a way for us to use hydrogen to produce steel, but along with Hyrex, we also have other areas that we use conversion. For example, a mix of clean hydrogen with other source of energy. And so in all of these conversions, we have a slight decrease in carbon emissions, but the cost increases exponentially. So that is the concern. And so because of this topic, the path to reducing CO2 obviously will incur a cost. And this is something that we must accept as a society and as a market. And then we have to think about how much of a cost are we willing to endure. And so we need to have social discussions. Maybe not, we cannot expect a social consensus, but we need to start a social discussion on how much of an extra cost is acceptable to the market. So what we need to do is to make sure that the increase of cost is not that high, but the decrease of carbon is very high. And so we need to develop technologies to reduce the price as much as possible. And businessmen like myself need to find the balance so that we can walk down the path of net zero, hydrogen, and other clean energy sources. And I would also like to add that related to cost, of course, we're not only working on Hyrex, but we're also working on renewables such as offshore wind. Offshore wind are projects that have a size of over $1 trillion. And so the price tag on these projects are so high, but the REC that you receive from these projects are also very large compared to onshore wind farms, for example. And so how are we going to use REC in the market to make sure that these projects make economic sense? And that would be a way for us to lower the economic burden and facilitate investments. So REC is something that we can utilize, and CF100 is another concept that we can use to make sure that we have market-driven paths towards net zero. And if we could have these market approaches, I think it would be helpful in overcoming the financial burden.
Next, we will go on to Equinor Senior VP, Sibe Gordon. So what would be the business potential of Korea? Let me ask this question.
Sibe Gordon, you picked Korea for one of the projects. I thank you very much for that. But what is the potential you see from Korean business in terms of offshore wind business in the future? Would you share your view on it?
Yes, thank you for that question. And I think I alluded to it in my introduction that part of the reason why we believe strongly in Korea as a very good market for offshore wind is the industry that you already have here. And we see a lot of that when we are looking at the different markets for offshore wind, that a lot of governments have strong ambitions around local content and local job creation. Sometimes that's wishful thinking that will also increase costs, but in Korea that is highly realistic, that the domestic industry will be able to play a significant role to develop these projects in Korea. And the reason for that, and let me use then floating offshore wind as an example. I mean, if you break down what that is, it's a lot of anchoring, it's a foundation, it's a tower and a turbine, a lot of steel and a lot of yard work. And that's obviously the strength of Korea to supply that. So I think that's already an extremely good starting point. But it's also a journey, right? So some areas you can deliver today, others tomorrow, and then again others in a longer future. So this is a journey that we need to go on together. But it creates an opportunity for Korea to create a home market that again will be very valuable to also take that out to other closer markets in the regions or also globally. So when we are looking at our projects in the west coast of US, we think of Korean supply chain as a natural contributor to that as well. So I think that's a part of how we need to think, and I believe Korea has a strong advantage.
감사합니다.
Thank you very much.
Yeah, for future business partner, wish that we have a great success for both countries. Thank you. 마지막으로 저희 엑슨모빌.
Our last question goes to President Karen Nariman of ExxonMobil Korea. So you have been in Korea for 50 years already. We had the oil and gas business in the past, and we are curious as to synergy effect between oil and gas and renewables.
Impressive that your company already has been in operation here in Korea for last 50 years, long history. You mentioned about synergy between your existing business and also the future low carbon solutions such as CCS. Would you please explain a little bit more on what synergy you can see in those new businesses?
Sure. Thanks for the question. I think we look at it both in terms of kind of near-term, mid-term, and longer-term. So given the challenge we're all facing, it's clear that we need to be able to deploy all available technologies to help us reach the net zero target. And so for the near term, we see great role can be played by LNG and natural gas. So if you just look at the charts that have been reviewed earlier, you see that about 40% of electricity is currently generated by coal. So there's an enormous opportunity to reduce emissions if you just substitute coal with gas. So that's your easiest kind of target, right? Then you look at gas and gas generation as being very flexible, and that enables deeper penetration of renewables. Because as we heard from our distinguished speakers, renewables need to have something else to be able to shave the peaks. And gas can play a great role in that. When we look longer term, we see that gas, LNG, when you especially couple it with CCS, can provide a long-term opportunity for low-carbon fuels like hydrogen and ammonia. And so we, given our history, given our expertise, we try to focus on things that we have the good experience with and good foundation, like CCS, hydrogen, ammonia. And we believe in Korea there is an ample opportunity to utilize all these technologies and LNG to achieve the targets that Korea has set for itself.
Thank you very much. 이렇게 세계적인 연구
So, global research institutes and world-class companies, well, how are they meeting the challenges of climate change? It's not an everyday opportunity that we can hear from these organizations and businesses. So thank you very much for providing this opportunity. I would like to also thank the audience for joining us. With this, I would like to conclude this panel discussion.
네, 다시 한번
Once again, a big hand for our moderator and the four panelists. A big round of applause. So we have been carrying out the session on the topic of creating new markets for the climate industry through low-carbon energy. That was a wonderful panel discussion. I would like to thank all the panelists and the moderator and ask them to take their seats. Thank you for your views, and also I would like to thank our moderator, Dr. Kim, for his contributions. With this, we would like to close a low-carbon energy session of the Business Summit for WCE 2023. I would like to thank you for joining us until the end of this event. Also, we do have gifts prepared for the participants here today. So if you go through the back entrance, we have our staff waiting for you to deliver you the gifts that we have prepared. Once again, I would like to thank everyone for your participation. And starting at 10 o'clock tomorrow morning, we have the ESG management session prepared for our business summit. So please, we ask for your participation. We will meet you again at 10 o'clock tomorrow morning for the ESG management session. I am Cho Ju-yeon, and once again, I thank you for your presence.